Looks at the double displacement reaction of sodium hydroxide and hydrochloric acid. The objectives are to recognize polyatomic ions and spectator ions, predict products of double displacement reactions, and understand the parameters of a chemical reaction. The hypothesis was that the anion OH from sodium hydroxide would form with the cation H from hydrochloric acid to produce water, and that the sodium and chlorine would form separate ions based on the solubility and the ionic equation. It was also predicted that when an indicator, which in this experiment was phenolphthalein, there would be a color change once it was added. The purpose of the experiment was to look at the fading of the phenolphthalein, which has been linked to forgery and counterfeiting. Knowing this information that can affect the increase or decrease of handwriting stability for such crimes as forgery and counterfeiting, all based off of a study found on pubmed.gov. The dilutions 1 mole of sodium hydroxide and 1 mole of hydrochloric acid, phenolphthalein, test tube, a plastic pipette, a burette, and a 50 milliliter volumetric flask were all the materials used. The sodium hydroxide was prepared in a 50 milliliter volumetric flask using the formula MCVC equals MDVD, where MC is the molarity of the concentration, while Vc is the volume of the concentration, and thus Md is the molarity of the dilution and Vd is the volume of the dilution. It was given that the molarity of the concentration was 5 moles, while the molarity of the dilution was 1 mole, and the volume of the dilution was 50 milliliters. Solving then for the volume of the concentration, it was found to equal 10 milliliters. Thus, 10 milliliters of sodium hydroxide was prepared in a 50 milliliter volumetric flask. An HCl, hydrochloric acid, dilution was also prepared in a 50 milliliter volumetric flask using the same process and the same equation with the same numbers MC 5 moles, MD 1 mole, and VD 50 milliliters, again finding the volume of the concentration to be 10 milliliters, which the 10 milliliters of HCl was prepared in a 50 milliliter volumetric flask. For the double displacement reaction, 3 milliliters of 1 mole sodium hydroxide was measured using a burette and placed in a test tube. 2 drops of phenolphthalein were then added to the test tube using a dropper. 1 mole of hydrochloric acid was slowly added to the test tube using a plastic pipette. The HCl was added until the color change could be observed. The observations of the reaction were then recorded, and the overall reaction can be seen where sodium hydroxide and hydrochloric acid formed water and sodium chloride. Sodium hydroxide and hydrochloric acid were both clear, colorless, transparent, high viscosity liquids. Once the phenolphthalein was added to the sodium hydroxide, the color immediately turned from clear to bright pink. However, it was still a transparent viscous liquid. Finally, as the acid was added to the reaction mixture, it turned from bright pink to a clear color again. This was once enough HCl was added. The color could actually be seen vanishing in the test tube. So the final product was a clear, colorless, transparent liquid. The complete ionic equation shown at the bottom of the slide shows the step-by-step process of what is taking place in the reaction. So you can see that the anion from one compound mixes with the cation of the other. The new ionic compound is soluble. We know this based off the chart from page 54 of the lab manual, also seen here, where on the left column, NaCl+ is soluble, and Cl- under the halides is also soluble. So now that we know we have a soluble compound, this explains why the ions separate instead of forming a precipitate. This result supports the hypothesis. Also, phenolphthalein is an indicator, so it changes colors when the base is present, which is why the solution changed from clear to bright pink. It is used to determine the endpoint in this acid-based titration. So our conclusions are that sodium and chlorine are both soluble, hydroxide polyatomic ion forms with the cation hydrogen to form water, phenolphthalein indicates the endpoint of the acid-based titration, and when a double displacement reaction takes place with soluble ionic compounds, the ions will separate instead of forming a precipitate. These were the references used, and this concludes the presentation of double displacement reaction.